Hello, everyone. Welcome to the Red Hat Data Services Office Hour. Maybe we should rename this to All About Data Analytics. Don't be surprised if the name changes. I'm Michelle DePalma, Red Hat Principal Solutions Architect, and today I'm hosting a Rhodes partner call with Intel. So remember that Rhodes stands for Red Hat Openshift Data Science, which is an add-on to our Openshift Managed Services. But today's focus is Intel's OpenAPI AI Toolkit. So I expect to have time for introductions. We're going to set up the topic, and then we're going to do a deep dive into the toolkit and include a demo, and hopefully have time for Q&A. So I'm here with Audrey and Rachel. Audrey, fellow Red Hatter, could you give us a brief introduction?
Of course. Can you hear me okay? I just want to double check that
and we
first.
can see you.
Lovely. My camera's working now. So hello, everybody. My name is Audrey Resnick. I'm part of the Red Hat Data Sciences team here at Red Hat. I have been with Red Hat for a year, but I've been with the IT industry for over 20 years, for full stack development to data science. And I have been, and as a data scientist, I have had the pleasure, or you could say the torment, of developing and deploying AI ML models into production. So in a world of Jupyter notebooks, VMs, GitLab runners, S2I, containers, public, hybrid cloud, on-prem cloud, etc., plus OCP, Openshift platform, I'm very excited to work with the Red Hat data science team and specifically share information on their Red Hat Openshift data science offering with you. Rachel will be introducing herself, and Michelle, I'll ask you just when we're ready just to let me go ahead, and then I'll talk about what I'm talking about today.
Okay. Hi, Rachel. Can you introduce yourself?
Hello. Yeah. So my name is Rachel Oberman. I am a technical consulting engineer here at Intel. What that means is that I work with the product teams for our AI offerings, in particular for the AI Analytics Toolkit, which I'll be talking about today, to make sure that our products are the best they can be and the customer voice is heard. And in turn, I also work directly end-to-end with customers, either on high-touch engagements or in enabling conferences and trainings such as this. And it's a very exciting job, and I'm really excited to talk about what Intel and Red Hat are doing today with Red Hat OpenShift Data Science and the AI Kit.
Awesome. Okay, so Audrey, I was going to ask you to kind of set the topic up. So I'm going to share, I think, Rachel, is this your screen I'm sharing?
Yes, I think so.
Okay, so, I think it's actually, is it a few slides down? But there's sort of an overview, and I just, we don't actually have this chat every week. So I think we need to remind people of where we are in our kind of ecosystem. So it would be there. Hang on, back up one maybe. No. It's our favorite slide. Keep going. This is a slide that helps me. There we are. Wait.
These are the slides I see. Maybe you could share your screen if you have the slide up.
Yes, I do. I see it. Nope, I'm sharing your screen right now. So Audrey, can you tell us where we are? Is this the slide that you were thinking of speaking to, or? Oh, did we lose her? We may have lost Audrey. Hang on. I think we're having technical difficulties.
Give us a second. I think we're all streaming from our homes, so
exactly.
it's something, when we do these things, it always happens once in a while for technical difficulties.
It does. Okay, so let's see. Hang on. Okay, I'll let her know we can't hear her, can't see or hear her at the moment.
I'm just going to go back to the title slides right now.
Yeah, honestly, if you want to start talking, you can. The idea was just to kind of set the topic up and see where we are in our ecosystem. And then right after that, we were going to go into all your slides anyway. So I think she's going to rejoin. She just dropped off. Okay. All right. So go ahead, Rachel.
Yeah, sure. So I think Audrey is supposed to go first and kind of set up the Red Hat and Openshift. So I should just go ahead and talk about AI Kit, and then maybe we could talk about AI Kit, and then we could go ahead and talk about Red Hat Openshift and how the
Yes,
two connect together.
sounds
That's
lovely.
a
Yeah.
good. I think that sounds good. So I'm actually going to go ahead and skip to that part, and we'll get back to that good stuff later on. But let's talk about first about the One API AI Analytics Toolkit and how Intel as a partner is enabling the AI kit in Red Hat OpenShift Data Science. So to understand the One API AI kit, the first thing that you have to understand is what is Intel One API. Essentially, this is a big drive by Intel, maintained on two specific principles. One is performance, and the other is open source programming across XPU. And I'll talk about what XPU is in just a moment. But essentially, with One API, and it's not just in AI libraries, it's not just in Python, it's also built in C++ and Java and so on. Basically, it's taking all of these low-level libraries and all of these beloved libraries and having them built on the C++ and SYCL standard, and having these all consistent so that you're not dealing with different standards or different compilers and so on and so forth. You're able to mix and match between the libraries. And not only that, but also having it be handled on all different types of hardware. So we're not talking about just Intel CPU, we're talking about GPU, FPGA, and so on and so forth. There's XPU, where X is like any kind of accelerator that you're trying to run on. And the idea is that once you are coding on, say, CPU, you should be able to port and be able to code to, say, like GPU and so on and so forth with much ease, rather than having this kind of having this very differentiated ecosystem, which is really hard to handle. Now, with that being said, what you see on the right is a mix of different things that are all part of the One API ecosystem. We have the languages encompassing One API. So we have C++, that SYCL standard, and that DPC++ compiler you see there that I mentioned, Fortran, and Python. We have libraries that Intel has built and maintained regarding these, such as 1TDB, 1MKL, 1DNN, 1DAL, and 1CCL in particular, which have a great importance to the AI kit library. And then we have a media and rendering libraries as well, Embrace, OSP, Ray, and so on. With One API, we actually go ahead and package many of these libraries to cater to different personas. So in this case, for example, the AI kit persona is a data scientist or AI developer, and I'll talk more about that in a moment. And beyond the libraries, we also provide tools to help with these libraries, such as the DPC++ compatibility tool and the vTune profiler. Now, that's everything that's going on with One API. And with this, you're seeing like all these libraries which are built in C++. And I'm sure if you're a data scientist or an analyst or something, you're like, I don't want to learn C++. That's a bit too much. I just want to go ahead and code in scikit-learn, and that's okay, because what I'll be talking about today is how we've added these like very performance optimized libraries, and we put them underneath these beloved frameworks such as TensorFlow, PyTorch, scikit-learn, and so on and so forth, so that in a drop-in acceleration format with like less than, I'd say, 5 lines of code, if that, maybe 2, I think is the average, if that, you can actually go ahead and accelerate these beloved libraries to a significant level, just by adding like a line of code or turning on an environment variable. And you don't need to go ahead and overhaul your whole framework or overhaul your whole pipeline to fit a specific framework or to fit a specific hardware. Now, with that, let's talk about that is what's powering underneath the One API AI kit libraries. And I'll be giving an example later on of how that works, as well as a demo. But let's talk about what is included as part of the One API AI Analytics Toolkit. And what you see on the right is all installed by default when you install the AI kit operator for Red Hat OpenShift Data Science. So as I mentioned before, the One API AI Analytics Toolkit It is Persona. Its goal is essentially to accelerate end-to-end machine learning and data analytics pipelines with frameworks and libraries optimized for Intel architecture. So go really fast, but also don't compromise the integrity of your pipeline in doing so, or don't, go insane in trying to fit a specific architecture or a specific framework. You can go ahead and use your favorite frameworks without having to fight with yourself to have your hardware work for you. And for this, in terms of what this is targeted towards, it's targeted towards data scientists, AI researchers, and so on and so forth, these accelerations in particular. Now, in terms of the actual optimizations that you get with the toolkit, you get in deep learning realm, you get Intel optimization for TensorFlow and Intel optimization for PyTorch, which are optimized by our OneDNN, our one deep neural network library from OneAPI underneath to bring you great accelerations to TensorFlow and PyTorch. We also have Model Zoo for Intel architecture. So if you want actually pre-trained models, which are really optimized already by Intel, you could go ahead and pull those by Model Zoo. And then we have the Intel Neural Compressor, where if you are a user and you have a great model that's coded in, say, like an instruction set like FP32, and you want to convert it to int8 for better usage and performance, so you take better memory advantage, but you don't want to lose accuracy, you could actually put it through the Intel Neural Compressor tool, and it'll go ahead and teach for you what the best way to do that without losing your accuracy. This tool was also previously renamed the Low Precision Optimization Tool, or LPOT for short. Now, in terms of machine learning, we have Intel extension for scikit-learn, which plugs in directly with the typical scikit-learn to add, but when you add 2 lines of code to it, and I'll be showcasing this later, you see huge performance benefit. And then we have optimizations for XGBoost included as well. In the data analytics realm, and this is really exciting for me personally, is that we have Intel distribution of Modin and the OmniSide backend that we help power and maintain with it. With Intel distribution of Modin in particular, you can think of it as distributed pandas, where in a single line code change, you could distribute your pandas data frames, which typically run on a single core, to all available cores. So if you hate waiting for read CSV to run for like hours on end, don't worry, this really speeds it up, and you don't need to worry about that. And in core Python, as I mentioned, pandas, we also have Intel optimizations for NumPy and SciPy and Numba that are backed by our 1MKL library. And we are also working on DPPY, which is part of that larger XPU drive that I talked about in the beginning, and enabling Python across all of your architectures and enabling these frameworks across all different hardware. Now that I've told you everything that's included, why should you care about this? Why should you use the OneAPI AI kit on Red Hat OpenShift Data Science? So besides just accelerating performance, maximizing and, really maximizing your performance, and also giving the opportunity to scale, we've actually given features in things such as scikit-learn and scikit-learn, where it's like you not only get this huge performance gain, but like say in the case of Modin, you could also distribute and scale your data now to where the typical library may not handle it. You could also streamline end-to-end workflows, so that all of these components that I listed before work seamlessly together. So you don't need to worry about, you have it all in one place. You don't need to worry about one thing not working with the other. All of them work seamlessly together. And this will help you improve your productivity, because if everything works together and you don't need to worry about version controls and it's all packaged together, you don't need to worry about like, oh, do I have to like downgrade my scikit-learn because of this like pandas thing that I'm trying to use. You're improving your productivity there, and also speeding up development in that, because in like say a case where you're trying to have these frameworks work with a specific hardware, you're trying to learn that, or you have to learn a brand new library to fit your specific framework. That takes a lot of time, a lot of hidden costs in terms of learning a new framework, or learning a new hardware, or how to optimize it. So by being able to skip all of that, you're saving a lot more time just by adding like 2 lines of code and using the Intel optimizations from this toolkit.
Rachel, we have a question.
Yeah.
Does the Intel distribution of Modin come packaged with Ray Desk?
Yes, correct. So the Intel distribution of Modin comes with different backends, and it has both a Ray and Dask backend, so you could go ahead and choose. And you could turn off and on the OmniSci backend, which is basically we've partnered with a company known as OmniSci. It's a really great partner, and they have a library known as I think it's the OmniSci SQL library that's running in the backend that brings even more performance to your Intel hardware, and you could turn off and on that. So you could use Ray or Dask as needed, depending on what you want. And if you are interested in, that's basically, you could use either or, depending on what you need. It's a really great library that's actually helping in the back end of Modin do the heavy lifting to distribute across all available cores. Fun fact. So with that, we've actually gone ahead and I'll be talking about this more. I'll probably come back to this slide when Audrey comes back. Essentially, we've actually enabled all of these great optimizations within the Red Hat Openshift data science platform. So we've actually enabled the AI kit in a friendly Jupyter Lab interface, including a pre-installed environment. So when you actually go into the Jupyter Lab, and I'll be talking about this later and showing it in real life, you actually get 3 pre-installed Conda environments that you could go in and have these optimizations there for you. Or if you want to go ahead and mix and match or make your own environments, you could go ahead and do that as well and create your own environments. But those 3 beginning environments to help you get started are there for you. And then for OpenShift, of course, this is all available as a Red Hat certified operator. And we also have opportunities for inference and deployment with deep learning frameworks such as Tensorflow, and working with the OpenVINO toolkit, which I believe was talked about previously on this podcast, for deployment as well. Now with that, I've been talking about how you get these performance benefits and how they're so great and how they actually work, but what is the performance benefit that you can actually see? And so I'll be showcasing this later in a demo using our XGBoost Dolphin inference optimizations. But as you could see from this diagram, you could actually connect and stack these different optimizations together so that you can optimize every single step of the data science pipeline. So starting on the left with the data pre-processing step, by using Intel distribution of Modin and just doing a single line code change, you can actually see up to 38 times faster ETL in the case of a US Census 2020 workload that we ran. ETL being where you're dropping nans and you're cleaning up the data to get it ready for your model training. Then using Intel extension for scikit-learn on that same use case, I think the ridge regression was used in this particular, essentially when you use it for both fitting and predicting, you could go ahead and see up to 21 times faster fit and prediction compared to the stock or unoptimized scikit-learn by just turning on those simple drop-in accelerations for an overall 40% accelerated performance. Now looking at the model training step, it's not only about scikit-learn, but I'm going to talk about it a little more just because I'll be talking about after this slide. With Intel extension for scikit-learn, as you saw in that use case, it was around 21 times faster fit and prediction, but you could actually see up to 100 times faster performance, or even 200 times. I think also in recent benchmarks, we've also done over 1,000 times faster than regular stock scikit-learn through the optimizations we have for our OneAPI data analytics library. We also, compared to our competitors, this could be compared to up to 10 times faster compared to NVIDIA GPU, or up to 5 times faster compared to running on an AMD CPU. Now, that's all great for data processing and classical ML, but moving on to the deep learning side of things in terms of model training, and just a full disclosure, we also have Tensorflow optimizations as well, not shown here. We have in PyTorch, if you use our PyTorch optimizations, you can see up to 1.55 times faster DLRM training by using the BS16 instruction set rather than FP32. And those same optimizations, if you go ahead and use the DLRM inference with it, you can see up to 2.8 times faster using the int8 instruction set versus FP32. Now, in terms of optimizations, actually as of 0.81 XGBoost, we've actually been upstreaming our training optimizations to the mainstream XGBoost. So if you go ahead and use XGBoost and you're using the HISP method, you already got those going. But we have even further optimizations and model inference, and that's compared up to 4.5 times faster inference compared to NVIDIA GPU if you use that. And for TensorFlow, if you use the TensorFlow optimizations and quantized inference, again, that neural compressor tool to convert your model inference from FP32 to int8, you can see up to 2.8 times faster quantized inference. Now, some of these numbers are really huge and some of these are smaller, but let me tell you, if that 2.8 times faster is a matter of between hours and minutes, that could be a huge gain for a data scientist, so they could spend less time waiting around and more time improving their model and getting other things done. So it's a really exciting thing to see. Now with that, let's take an example on how a user will go ahead and use one of these, some of these optimizations. I will begin by talking about Intel extension for scikit-learn, and then I will be given an example on how to use our XGBoost and $Pi optimizations. And you may be thinking to yourself, what is $Pi? But don't worry, I'll help you through it. It's just, you could think of it as basically the Python version of that one API, $1 C++ library I talked about in the beginning. So don't worry about that. So in terms of, if I am a user, I'm using the AI kit operator on Red Hat OpenShift data science. How can I actually go ahead and use these optimizations for you? So let's take, for example, I'm trying to use this for a support vector classifier, as is in the case of this little small code snippet seen here. What I will want to do is I want to use Intel extension for scikit-learn, which is powered by the OneAPI data analytics library, and its Python API equivalent $Pi, which can also be used directly if you so choose. But you could also just go ahead and use the Intel extension for scikit-learn and stay within your regular scikit-learn API. So I'm ready. I know a bit about how to turn on scikit-learn. Let's go ahead and do it. So I take my original code, this regular scikit-learn code, and I go ahead and add these two lines here from sklearn.ex, import patch_sklearn, and then I use the function patch sklearn. What this is telling the computer is, hey, anything that could be optimized by Intel extension for scikit-learn and the OneAPI data analytics library, which is one of the most optimized machine learning libraries we have here at Intel, please do so now. If it is not optimized by the $1 library, please just use regular scikit-learn. So there's no loss, only gain in this case. And there's also opportunities where if you don't want to turn on everything that $1 can optimize, you could just turn it on for a specific model or whatever you choose. And you could also turn this off at any time with the unpatch method. So you would just add UN at the end of this. And that's all you would need to do. And suddenly your SVC fit and predict are really optimized. Now, this already comes pre-installed for you as part of the AI kit operator, but if you want to go ahead and try it out as just a component and just do it in like a sandbox environment, it is available in the default Condas channel, the Intel channel, Conda Forge, and pip install as well. So it's also available there. Now, in terms of the actual, what this looks like in terms of an actual speed up compared to the regular scikit-learn, you could look at the chart here. So on the left is a bunch of popular algorithms such as k-means fit and predict, random forest, and so on and so forth. We even optimized train test split, a very popular processing method used in the scikit-learn library. And all we've done is taken our code, and we've just gone ahead and added those two lines of code. And this is how much speed you could see. So in some cases, as in the case of support vector classifying predict on the MNIST MNIST data set, you can see up to 200 times faster. So that is like really like the power and the kind of performance gain you could see by just adding that simple drop in acceleration. There's no other further changes needed in order to get that acceleration. Once you use this patch method, everything is turned on for you. Again, it's very flexible where if you want to turn it off at any time, you can do that. Or if you want to go ahead and just do a specific algorithm, you could do that as well. But the results of being able to actually go ahead and use this is very, very huge. And you could think like all I did was add 2 lines of code, and using the AI kit operator, this is what I'm able to do, which is a really, really huge thing. If you think about having to change your whole workload to try and get this performance gauge, just being able to get this in 2 lines of code and not having to deal with C++ or anything that you would typically need to do. Now, before I move on to the next bit and then going on to the demo, as I explained, this Intel extension for scikit-learn is powered by the OneDAL library, the One API Data Analytics Library. What we've done is that library is coded in C++, and we've gone ahead and put it into a Python-friendly library known as DAL4Py. So it has a Python equivalent. So you can think of it as a cake where there's OneDAL underneath C++, then there's DAL4Py, which is the Python equivalent, and then on top you have Intel extension for scikit-learn. But that DAL4Py library has more capability than just accelerating the scikit-learn in Intel extension for scikit-learn. It also has optimizations such as distributing linear regression and other algorithms found in scikit-learn. So if you actually want to go ahead and distribute or use online streaming mode, you could actually use the DAL4Py library directly. This is also included in the AI kit operator, but we only recommend that if you really need to. It's a very friendly library. If you know scikit-learn, I'm not lying. This is a very easy library to pick up. But besides that, it also has accelerations for other libraries that we've included, such as XGBoost and LightGBM. So if I'm a user and I have this great optimized X library that's using those upstreamed training optimizations that we already upstreamed to the regular XGBoost. But I want more. I want to optimize in my XGBoost inference. Well, you can do that by using it by converting it into something that DAL4Py can read and then running it in with DAL4Py. And I'll be demonstrating that in just a moment in the AI kit operator for Red Hat OpenShift Data Science or ROADS. So if I have gone ahead, I finished the training part of my XGBoost model, and this capability is also available for the LightGBM library, but we're going to be talking about XGBoost for right now. I'm ready to go ahead and use inference. What I can do is basically take that pre-trained model here. I can import DAL4Py, which again is already imported for you and is available as part of the AI kit operator. And I will just go ahead and call this and say get GPT model from XGBoost and say, hey, please convert this model into something that DAL4Py can read. And then afterward, I'm just going to go ahead and call the gradient boosting prediction as needed with this, which is saying, hey, convert this into something that DAL4Py can read, and then go ahead and use the gradient boosting classification prediction, which I would usually use in XGBoost, and just use it in the DAL4Py one. And what this is doing is taking advantage of the DAL4Py optimizations for gradient boosting inference. What this means is more efficient model representation in memory. I'm taking advantage of the AVX 512 instruction set and just better cache locality usage. And what this will happen is that you see this huge performance increase compared if you were just using the regular XGBoost inference call. You see, in this case, up to 20 times faster speed up when you're using these 2 lines of code to go ahead and convert your model. And there is no accuracy loss when you actually go ahead and do that. So again, just doing these simple little code changes can prove really profitable if you are looking for better time usage and better cost usage for this. So being able to do this, a 23 times performance boost is really huge. Now, with that, let's actually go ahead and demonstrate what this actually looks like on the AI kit for Red Hat OpenShift Data Science. and then we will try to go back to Audrey if possible. So I'm actually going to stop sharing my screen for a moment, and then I am going to reshare with the demo and show off what AI Kit looks like on Red Hat OpenShift Data Science, aka Rose. And let me move my screen, and there we go. Now I'll go ahead and share.
Okay, all set. I see it.
And okay, you can see my screen?
Yeah.
Okay, awesome. So here we are in the Red Hat OpenShift data science platform. So as you can see here, we are in the applications tab here, which is basically if I have gone ahead and installed the Red Hat OpenShift data science operator, and I have gone ahead and launched into it, if I've also installed other partner software that Red Hat has collaborated with, such as Intel, it will also show up here. So in this case, I have already pre-installed the Red Hat OneAPI AI Kit container, as well as the OpenVINO toolkit, which is also available on Red Hat OpenShift Data Science. So if I go ahead and play the video, I'm probably just gonna go ahead and wave my cursor around to say, look, it's there. Now, besides showing what's enabled on the Red Hat OpenShift Data Science platform, there's also all these great resources and optional applications that you could go ahead and learn about. So in this case, I click the AI Kit application here, and it will come up with information on what is AI Kit, as well as how to install the operator. So all of that is available there. And besides that, there's also resources available from Red Hat and its partner software. So if I actually go ahead, and I think I'm going to go ahead and search AI, you will actually see AI Kit pop up here, and it'll come up with a documentation to help you get started. Now, after all of that is done, say I've gone ahead and I finished reading the documentation. It's amazing. I have it installed. I'm really excited about using AI Kit. Let's go ahead and launch it. Now, one thing I want to disclose is that for the sake of this demo, it's not going to show, just based on how it was recorded. But typically, this would show a spawner screen with all the available containers that you could select. And when you go ahead and pick the AI Kit tile, AI Kit will already be pre-selected. So you just have to go ahead and do an extra thing where you click AI Kit and launch, and then it will show to where it's going to now, which is the Jupyter Lab environment of AI Kit, where you could do a lot of great development using our optimizations and pre-loaded Conda environments. So if I go ahead and stop the screen here, what you'll see on the left is a couple of things. First of all, we have the models.git, which is where the models do with those pre-trained models for our deep learning libraries are located. We have the OneAPI samples folder, as we have actually already gone ahead and given you samples to help users get started. There's also more samples that are linked in this welcome page I'm looking at, but we'll talk about that later. And we'll also be showing off one of these samples today as a demo. And then there is also the AI Kit welcome page. So the AI Kit, as you can tell, as I talked about in the beginning, there are a lot of optimizations here and there. And so you may be wondering, like, well, where are they in these pre-trained environments? And what if I want more information? So I would definitely recommend if you install the AI Kit operator to get started with the AI Kit welcome page. As you can see here, it just basically gives an intro to AI Kit, as well as environment package information, like what is where. So in the, say, for the scikit-learn, XGBoost, and Modin environment, which if I do not highlight, maybe it will go ahead and show Intel Modin, Intel extension for scikit-learn, which we just talked about, Intel distribution of Modin, including our NumPy and SciPy optimizations, and Intel optimized XGBoost. And if you go ahead and click on each of these links that are a little bit faded right now, it will go ahead and take you to more resources on that. Now, if that's not enough for you, we also have provided more resources for you to get started, such as access to the AI Kit website, AI Kit code samples that include more code samples than what is included here, as well as the AI Kit release notes, so you could get more information on that. So I'm going to go ahead and do that. And if I've gone ahead and finished the welcome page review, you will see when you actually click that plus tab to start a new notebook, you will see these, again, these pre-configured environments. So in the Intel PyTorch and quantization tool, you'll get the neural compressor and Intel PyTorch optimizations. In Intel Scikit-learn, XGBoost, and Modin, as I just mentioned, you will get those kinds of optimizations. And Intel TensorFlow and quantization environment, you will get the TensorFlow optimizations and the neural compressor as well. So besides having these available for the samples, you can go ahead and launch and experiment in those Conda environments, or if you want to create your own environment, you could go ahead and do that for you. And it also has a terminal access, which, if I recall correctly, it's going to show off here. So I'm just going to go ahead and highlight over that. And the reason that this demo is recorded, just as a full disclosure, is that you'll see in a moment that it takes a while for the unoptimized XGBoost inference to run. So I don't want us waiting around for that to run. So that's why it's that's why it is taking that is why it's recorded. So again, there's these resources for you. So say I've read this and I'm like, okay, I want to get started. Let's go to the samples. Now there are 3 samples. If I pause this here, we have one use case using the Intel distribution of Modin and the Intel extension for scikit-learn optimizations. We have the Intel optimizations for TensorFlow and the LPOT tool that is now renamed to the neural compressor. And then we have our Intel optimized XGBoost sample using our XGBoost training optimizations and that are upstreamed, and the $per-pi inference method that I talked about right before going into this demo. So we are actually going to go ahead and show off those XGBoost optimizations and that $per-pi inference. And I will go ahead and click into that notebook. So as you can see here, this is the sample. And what is going on is that this is an end-to-end sample. The goal of this sample is that you're a data scientist, essentially, and you are trying to use the Higgs data set to basically predict if a particle is going to produce a Higgs boson process, or it's not going to. So if it produces it, it will mark it as we'll classify it as a 1. If it does not, we're going to classify it as a 0, and we're going to analyze and predict using the information on the particle features and functions of those features. That's all you need to know. You don't need to know any physics. Just basically, if it's a Higgs boson, it's going to produce a 1. If it's not, it's going to do a 0. And this is based on the information from the data set or the particle features. So as any data science workflow first starts, we'll go ahead and start by importing and organizing the data. So we're going to go ahead and do that here. You can see I've already imported XGBoost and $per-pi, and we're just going to go ahead and pull the model and train test split. Now I'm actually going to go ahead and run through this very rapidly so that it can run while I'm explaining it. So we've already explained that first part. So it's going to go ahead and pause there. And in this case, I'm only using, the Higgs data is pretty vast. So we're only using the first 100,000 rows in this case, but we will still be able to see a performance speed up with that. Now, once I am done with importing and organizing the data, I'm going to go ahead and train the model. So as you can see here, I am using the XGBoost classifier from the package. And I'm using these different parameters. As you can see from tree method, the his parameter is marked, meaning that we are taking advantage of those Intel optimizations that are upstreamed to the XGBoost library. And let me tell you, this is going to take a bit of time to run just to train the model, but I've run it without the optimizations before, and it takes quite a long time. Like I think in this case, it takes 2 minutes to train the model, and I'm going to go ahead and skip ahead to that part. But in many cases, you know, compared to the unoptimized, it is a huge performance gain. So I'm going to go ahead and pause and wait here, and I will go ahead and skip to where it is going to finish training. And it should be right now. Yes. Give it a moment. There we go. So after it is done training, it will go ahead and just print it out and say, hey, I'm done training. Here's your model object. And after that, we're ready to do some prediction. Now, maybe I'm kind of a skeptic, and I'm like, well, is the $per-pi prediction faster? Let's go ahead and try it out. So what we're going to go ahead and do first is that we're going to try it without the $Pi optimizations for gradient boosting first. And we're just going to do a typical XGBoost prediction and add a timer for that, and as well as an error count, because even if the Pi turns out faster, is it going to be as accurate? Now, after that, I'm going to actually go ahead and run the Pi prediction, which is again using those two lines to get the to take this model that we just trained and convert it into something Pi can read. And after that, we are going to go ahead and run the prediction object and go ahead and use that model that we just converted to Pi and run that here. Now, and then we're also going to go ahead and compare the accuracy and use a timer there. So we are actually going to go ahead and run those now. I think they already pre-ran at this point. So as you can see here, I'm just highlighting, these are the lines that are running to give that performance speed up. And let's go ahead and see the results. So this is the printout of the comparison of the, if I go back and pause it, one moment. So if I go here, this is the regular XGBoost inference results, and this is the Pi gradient boosting inference results using the same exact model. And as you can see here, both have the same error count and the same accuracy score. And the prediction time in this, again, this smaller data set for the sake of the sample, the XGBoost prediction time took around like 25 seconds. And the Pi inference time took around 0.06 seconds. And if we go ahead and actually visualize that, you could see here that this was approximately a 3.47 times speed up just on that little data set. So again, that huge performance gain that can really scale up as your data set size or your training model gets very complex. Now that's great. What about accuracy? And the great thing about these Pi inference optimizations, which are again those like two little simple line converter changes, is that there's no accuracy difference compared to the typical XGBoost stock inference accuracy. So you could go ahead and get a huge performance gain by just adding those two lines of code, and after that, just using the same accuracies you keep coding for you. So that's just a bit of an example of using the AI kit of what you can see, the kind of optimization gain that you could see with the AI kit operator on Red Hat OpenShift Data Science. So with that, we've just finished talking about AI kit, some of the great performance optimizations and how they actually look like in code, as well as a demo of what it looks like on the Red Hat OpenShift Data Science platform. Now, I think I'm going to turn it over to Audrey to go ahead and talk more about the Red Hat OpenShift Data Science platform and how exciting to have an AI kit operator on this is. So let me stop sharing my screen. And Audrey, are you going to go ahead and share your screen, or should I reshare these slides?
Oh, how's your connectivity?
It's okay. It's okay. Maybe I should share?
Yes,
or, yeah. Okay. Yeah, so I will go ahead and share on slide 2, and we will talk about where you can run these AI kit optimizations with Red Hat. So let me go ahead and present.
Okay.
And Audrey, whenever you're ready. Force mute. Oh no.
Sorry, I couldn't see quite what it said. Hang on, Audrey. Here.
It said unmute her. Unmute her.
Oh my she's not muted. No, she's there. Sorry. No, you're as green as Rachel is. No, huh?
Oh no. Maybe try unplugging your headphones. Maybe it's an audio setting thing, because I had to set my default differently for this.
Right.
No.
Nothing, huh? I'm looking at my settings. Hang on. I don't think there's no more for me to do for a guest. It's sort of your. Okay, I'll put you in the background. I'll bring you back. Okay, let's see. Hang on. And she's back. We're all learning our new platform. Any luck? No, nothing. So,
So
okay.
I think with this, I think with this, we've actually, there was a great presentation that Audrey has already done with Ryan Loney on the OpenVino toolkit powered by Red Hat Openshift Data Science. So if you want to go ahead and learn more about the how to get the AI kit, what is Red Hat Openshift Data Science, and what the AI kit operator looks like on it. You already got the second part since you already know all the AI kit optimizations that I ran through, but just because of technical difficulties, again, we're streaming from our home, so this can happen from time to time.
Absolutely.
I think it might be good to go ahead and look at those Red Hat OpenShift Data Science resources. But just from my personal experience with Red Hat OpenShift Data Science, it's a really great platform. It really helps you. Yeah, I know. Audrey's like, it's awesome. That's awesome. It's an awesome product and all that. So, but Red Hat OpenShift Data Science is basically this really great open hybrid cloud platform, and really is powered and focused on AI data scientists to basically help you get rid of that really complex infrastructure setup and give power back to the data scientists. And once you are using the Red Hat OpenShift Data Science platform, you could take that, no more infrastructures or hassle with cloud or hassle with Kubernetes or anything like that. And then you could couple that with the power of AI Kit, where you no longer have these, have to overhaul your whole pipeline to go ahead and fit a certain hardware or infrastructure. So really coupled together and really giving power back to the data scientists. And I'm just going to go ahead and flash the features of the Red Hat OpenShift Data Science so that users can read. But again, really great hybrid cloud service that you could use on different vendors and really speed up your data science workflow. And I'm going to go ahead and flash the infrastructure of all of the great partners that Red Hat is partnering with to bring these optimizations on behalf of Audrey. I hope I'm giving it justice. I'm getting a thumbs up, so I think I'm giving it some justice. Yeah. So in terms of the partners, the One API AI Kit sits up here with the customer managed ISV software, and Intel AI Kit is a partner software. So I'm actually going to go ahead and skip to the end here and represent. And so if you want to learn more about the AI Kit and how to install Red Hat OpenShift Data Science, here are a couple of resources that will also be available for you after this presentation. So if you want to go ahead and download it, I definitely recommend clicking this link, which will link you to the Red Hat Marketplace, where the AI Kit operator can be installed. And beyond that, just some notices and disclaimers about the numbers that I showed. But I really encourage you to go ahead and try out the AI Kit operator on Red Hat OpenShift Data Science today. So with that, I'm going to stop sharing my screen.
Well, I want to thank you. It was really impressive, actually. And I'm not a data scientist, so I didn't have questions to ask, but I was impressed. And Audrey, I want to thank you for trying so hard to join. I will have to, and of course, I want to thank our listeners for bearing with us as we go through all of our new technical issues on our new platform and everything. So I don't see any questions at this time. So I'm going to go ahead and wrap up, even though we're a few minutes early, and I will do my best to make sure that we promote these demos and videos that we've done on our product page, so anyone who wants to come in later can just go look at the Rhodes product page and find them. So again, thank you both. I really, really appreciate it. Anyway, have a good day, everybody. Take care. Bye.
Bye.